very nice to be here. It's my very first time in this school. Interestingly, I was talking to an old student, an old client this morning, and he informed me that he actually went here. So I'm actually going to show you what we worked on together a few years ago. Actually, one of my old bosses at Lifestyle Design, Mark Tapinair, I believe, did a lecture here as well. I worked for him for 4 years, many years ago. I was telling Wesley earlier that I was actually the second longest lasting employee at that company at 4 years. So a lot of history and a lot of connections here. But today I'm going to give you a pretty special talk that I have given before, but I modified slightly for this audience in particular. As Wesley was talking about earlier, I have worked in many different industries, and you will see that in the work that I showed today. So the talk today is titled Designing Between Earth and Space, and this is really what my career has been about. But before we jump into a little bit more like portfolio work, an array of the type of work that I've done, let's talk a little bit about what makes my life so special. I'm privileged to have gone on many different places on this planet. I think I've up to like 50 countries at this point. Yesterday I was in Colombia. 2 weeks from now I'll be in Mexico City. And travel is very important in my life because it is what inspires me to observe how people live, observe differences in the way people make decisions for their own lives, and understand culture deeply, shutting up, because I talk a lot at work, and sometimes you just have to shut up and listen. And I have a big fascination for places that live very differently, that speak different languages, that have different customs, as well as deserts. Because deserts, whether they're hot deserts, Arctic deserts, give me a lot of creative space to do the work that I do. And so these are just a few of the places I've been to. So I hit about 10 countries a year. I am on the road constantly, and especially right now because I actually was living in San Francisco for about 12 years, and 2 years ago I packed my bag and started traveling the world. I haven't had a home in 2 years, and it's been really fantastic. I can really see how all of these travels have informed a lot of the way I think and the way I see the world and the way I share it with everybody. One of the things that I do when I travel, when I have time, is I illustrate my travels, the people that I meet, the architecture that I see, the food that I eat. And it all started because I realized that there are certain things about the way I function, my body functions, my brain functions, that are a little bit different from other people. Like, for example, I don't remember being in the places where I took pictures. Some people can do that, I can't. So the only way I was able to remember the places that I visit is by painting them, by spending 20, 30, 40 minutes doing a portraits or building an architecture in color. And what's nice about that is that it also makes the experience very multisensory. So I actually remember the smell, the noise, the background, the people, the dirt on the ground of every single place I've painted. I could not do this with photography. So I encourage each and every one of you to find what works for you and to go all in. I filled up 8 notebooks like this, each of them about 50 pages of watercolors this way. Watercolors is very great because I don't really draw a lot at work because I don't have time, but this allows me to spend the time to observe light and shadows and expressions and all the imperfections that make life very beautiful. And because as industrial designers, we always strive for perfection, for the minute details that turn a good product into a great one. And it's nice to see that nature, humans, and everything in between that's out there is actually full of imperfection that make them beautiful. So back to what I do for a living. So in my introduction, there were 2 main kind of like careers that I've developed over the last 20 some years. I've been out of school. Number one, industrial design. I think all of you know what that is. However, the way I practice it is very different from probably the way you're taught or the way the vast majority of people do it out there. The way we practice it at my firm, which is called Nonfiction, is that we always go after super high cutting edge technology that may sound or may look like science fiction. And our job is to make it real and commercially available. And so, a lot of the work that you see out there is, putting an enclosure or a skin on existing, ergonomic or electronic package. I have absolutely no interest in that. I've done that for probably the first 10 years of my career. I know how to do it. And now, having the curiosity to merge other disciplines in order to come up with novel ideas that are rich in intellectual property is very much, at the core of what we do. So there are many industries that we touch. You can see a few of them here, a lot of healthcare, everything from, things that you see in the operating room, brain implants, wearable, things like that. Aerospace, that's the other career that I've developed. I have a degree in space architecture. The year I graduated with my master's in space architecture, we were 4 people in the world to get that degree. And I was one of them. I was also the youngest in the world to ever get that degree. Also designed a lot of wearables. So wearables are pretty interesting because they are a merging of deep technology, like a lot of closed loop systems, a lot of stimulation of different parts of the body, and they mix hardware and soft materials. And there's a skill that comes with that, along with ergonomics. Climate technology is becoming very big in what we do. We do it for very sophisticated companies that are doing very complicated and expensive products, and we do also very, very low cost renewable energy. And finally, consumer electronics. So I spent a very, very vast majority of my early career doing consumer electronics. Everything from, I think I spent 5 years doing audio products. Everything from super low end to super high end, everything related to computing, sensory design, and a lot of the last couple years have been focused on robotics, humanoid robotics, infrastructure, and things like that. So yeah, so these are just a few of the industries that we do. But what's interesting is that when we developed this company 10 years ago, we really wanted to be industry agnostic, right? I'm not married to a particular specialty. Everything that we do is the first time anybody has ever done it. So there are no experts out there, and there's a lot of searching for the right solution. So yeah, having to work in all of these industries forces us to be very curious, to be very creative, and very often to make a case for design in industries that don't even understand what design is. There are 3 conditions to work with us in nonfiction, which is pretty strange, I guess, for a younger company. Our company is about 10 years old now. We don't work with everyone. We say no a lot, actually. And there are 3 conditions to work with us. Number 1, we only work on innovation like never done before. If you're just trying to copy your competitor or make a product that's not bringing anything to the world, no thank you. Number 2, you've probably seen the 17 Sustainable Development Goals put together by the United Nations in 2015. These are basically a guideline that says, why are we designing, who are we designing for, and what is the positive impact that can come out of this design. So we ask every single one of our clients to satisfy at least one of the SDGs before they work with us. And number 3, that is extremely important, and I wish I saw more of it, is we only work with companies that have a path to execution and success. Because everybody has a good idea. Everybody has noble values and wants the world to be great. But very few people actually know how to do it or have the resources to do it. So having clients that have the right team, the right background, the right network, the right budgets is extremely important to make sure that the great ideas that we come up with actually make it all the way to manufacturing and distribution. So one thing that really defines the work that I do and the way I see design is that I don't have a passion for design. Couldn't care less. I could quit design tomorrow. I don't care. I use design as a tool to get to the end goal, and the end goal is meaningful innovation, right? I just happen to do design. I could do business doing that. I could do science and all that. So the way we reach meaningful innovation, specifically the way I do it is by having a little bit of business, having a little bit of art, technology, science, and having design connect all of these things together. And that forces us to be extremely curious, right? We constantly work with the most prominent neuroscientists, the most prominent business people, the most prominent, like Silicon Valley technologists to inform us on how to best design products. And we have to have our eyes open, our ears open to understand what a good product is. And we have to communicate with them. We have to work with manufacturers, with engineers, with everybody who can actually help us push the idea forward, because designers cannot and will never do it by themselves, especially in the 21st century, right? I think one of the main differences between the 20th and the 21st century in terms of like what we put out is that we used to value expertise in the 20th century. Every time you wanted to start a project, you would find the Nobel Prize laureate or PhDs in whatever field. You'd listen to what they say and you just like do that. That worked for a while, but we live in a world that does not function like that anymore. Expertise is great as a reference, but expertise is only one of the many elements necessary to make a great product. You need to have creative people. You have to have people who have the rigor of science and building technology that works. You have to have a business case, and you have to have the emotion that carries it all the way to behavior change. One of the things that I see happen too often in the process of design or using design in the process of launching products is handing off. You start a process with perhaps strategy, industrial design, user experience. You do your job and you hand it off to an engineering team, and then that hands it off to a manufacturing engineering team, and then it goes on like that. That is the surest way to never have your design end up the way you want it to be, because people are going to make decisions without consulting you, and a lot of frustrations in a lot of designers' careers stems from that. And so in order to remedy this, we use a methodology called lean product development, which is essentially the overlapping of disciplines and forcing all of these different disciplines to work together from the beginning all the way to the end. You see the first triangle in the beginning here is our involvement in industrial design. We're there from the beginning, and we're there all the way until we sustain operations after manufacturing is done. We have to be in the room, especially when we're not invited. That will be half of your job. Half of your job is to do the design and to force creativity when it's lacking. But the other job is to defend design, to defend the decisions that we make that turn a good idea into a good product. Because everything in the process will work against you. Business is going to have some lame excuse as to why that detail that you really wanted in the design should not be there, usually cost. Or engineering will not want to spend an extra month developing a detail that will turn a good product into a great one. And so you have to be in the room, you have to argue, you have to force yourself to be there. Throughout my career, I've always been shocked by how many people 10, 20, 30 years in their careers had never been to a factory. Actually stop trusting and listening to people who say that. Because if you don't go to a factory, if you don't know how things are made, if you're not on the line, you're not talking to the people putting the components together, if you don't understand what it takes, why it costs this much, that's a different career. That's not industrial design. So as early as you can, go to this factory, impose it on your employers, and actually a couple times I had to like buy my own tickets to China, right? Because people didn't want me to go for whatever reason. But all of that knowledge that is accumulated by exposure is what makes the difference between a good and a great designer. So in terms of process, kind of illustrating what I just talked about, is the fact that we never work alone, right? As designers, we work with strategists, we work with mechanical engineers, electrical engineers, and we work together the whole time. From phase one, research definition, you don't disappear in a room, do a bunch of mood boards, and wish for the best. That can only happen in a very effective way if you have marketing people in the room, business people in the room, all the decision maker to start trusting your process from the beginning. So when you jump from phase one to phase two to phase three, all the way to the end, they are part of the story. They feel included. They feel like you've listened to them as you make decisions, and you will feel the same way, right? And so I encourage every one of you from the beginning of your career to be in the room every time a decision is being made. It will make a huge difference. I can tell within 5 minutes of meeting someone if they have that skill or not. But the whole process, there are many different ways we do the process of designing anything, but this is like a kind of like a blanket way of doing it. So research definition is where we start. What are we doing? Why? For whom? Conceptual design. So there are many debates about like what is the right way to do conceptual design. Some believe that you have to do that with sketches. Some believe you can do that with CAD. Some believe you can do that with storytelling. I'm agnostic to that. I don't care how you get there, as long as the story is strong and you know how to follow through. Product architecture is when engineering comes in full force. They come in with their constraints, their alignments between the cost of things, the number of parts, the bill of material costs, things like that. So there's an alignment between the conceptual design and the requirements of mechanical and electrical engineer at that point, and other types of engineering if necessary, like acoustic and optics and things like that. After that, design refinement is when everything merges together. We've learned a lot from testing on prototypes. We've learned a lot from engineering. We've learned a lot from design and colors and materials and things like this. And we're putting everything together into making a product that doesn't say 30 things, but says 1 or 2 things. Right? And then finally, delivery and testing. We deliver different types of prototypes depending on what kind of product we're doing. Sometimes it's an ergonomic prototype. Sometimes it's a cosmetic prototype that looks and feels and has the weight of what we want. And sometimes it's a mix between a functional prototype that has all the bells and whistles electronically, and it looks and feels exactly like what it is. And it really depends on like what the client needs, but that's usually where our process of delivering a design essentially ends. And so now I'm going to go through a few of the work that we've done in nonfiction. So the work that you're going to see here is probably the last 8 years. So the first 12 years of my life, of my career, I've worked on many of the different things, a lot of like action sports product, a lot of audio product, luxury goods, and things like that. But I'm going to start about 8 years ago. And so I mentioned earlier, I'm a space architect. So a space architect is someone who is trained to design how astronauts live and work in space. So, I've been doing this for 20 some years, and I get to work with, flight surgeons, space medicine experts, aerospace engineers. I understand their language, and I'm actually, because I'm a creative in the space industry, there are actually very few of us still to this day. Even with the birth of the Blue Origins and the SpaceX of the world. And what's very important when we think about creatives in the space industry is traditionally the space industry is all driven by engineering. What fits into the payload fairing of the rocket, how much mass, how much volume, and basically we've been creating space stations and crew transfer vehicles that include a lot of the life support system necessary to maintain life, but doesn't take into account the human side of life, right? The fact that we need certain environments to sleep properly, to eat properly, to work properly. All of this is kind of put on the back burner, and we pre-select astronauts to survive missions instead of creating environments that lets them thrive. So this is a project that we did with a company called Aerospace, which is based in Colorado. Aerospace is one of the few like commercial space companies, commercial meaning that they're outside of like a government agency, that is developing space modules. And this particular one is called Life, which is a large integrated flexible environment, and it is inflatable. The advantage of having an inflatable structure is that you can have a fairly small rocket's payload fairing, so basically the top of the rocket, and then you can have that volume expand in space, increasing the pressure and making it livable. And because what's happening is that the type of rockets that we have right now, if you're not counting Starship, are quite small. And you cannot fit all the things that you need in a lot of it. So if you go see like images of the International Space Station, it's quite tight, and there's a ton of things on the inside. So we're trying to like move away from that model. So a space station that we're working with is Blue Origin's orbital reef. So this is being developed right now, although it's been put on hold because now Blue Origin is more focused on the moon, which makes sense. But the idea was like for Aerospace to create those inflatable structures and to dock them to basically a long tunnel that would serve as let's call it a space street that is managed by Blue Origin. And so the idea here is to replace the International Space Station, which will retire very, very soon. It's been up there for 26 years. I believe, depending on the modules, was designed to last about 15. The reason why we're able to like extend the lives of space stations so long is because it's so damn expensive to ship them up there and to keep them alive, right? And so the idea of this would be to replace it as not only a laboratory in space, which gives you access to microgravity environments and all the scientific experiments that you can do up there, but it will also open the doors to a space economy. So space economy means that you are going to have people who pay to go to space for different reasons. Some of them might be tourists, who want to have a joyride. And then some of them might want to do some research. So pharmaceutical research, there's a lot of research in manufacturing of certain materials like semiconductors. Like for example, right now there's a huge battle between AI and the need for data centers, quantum computing and things like this. And a lot of that technology takes a lot of time, pollutes a lot of this planet, and it would really benefit from being in space where it's extremely cold, and you can take advantage of that cold. But also you can manufacture certain materials much more efficiently if you have a microgravity environment. For example, proteins, when you create protein crystals on the surface of the Earth and they turn the wrong way. I don't know if you've ever seen like a protein structure. It's like quite twisty. But if it twists the wrong way, it can actually kill whoever you inject that with. Whereas in space, you can control that a lot better. So that's one of the many advantages of developing science in space. And we're involved in all of that. But coming back to the way we designed the interior of that inflatable station, we wanted to take advantage of the beauty of the Earth. Again, coming back to all of that travel that I've been involved with, taking pictures of these textures and this, manifestation of nature, of different colors, different depth, colors, smells, and ways of being that in many ways could be translated on how we live in space. Because in space, everything is artificial. The only thing that will feel natural is the cupola or the window back to the Earth that allows you to see the Earth. But everything on the inside is just equipment to keep you alive, equipment to work with, and equipment to, work out, feed yourself, and things like this. Right now, the way they exercise in space is, it looks like tubes and machinery that you, put together very quickly from like Home Depot, something like this. Is nothing very exciting. What is very important about working out in space is that because the human body has evolved for millions of years to work with Earth's gravity, which is 1g. When you go to 0g, everything changes. The blood the majority of your blood is actually on the bottom half of your body, now is spread evenly throughout your body, which means that your skull has a lot more blood, a lot more fluids in it. And so that doesn't help with vision. You can actually get space blindness. The fluids actually impact the way you taste food or your orientation. Typically, when people go to space, the first 3 or 4 days, they're throwing up all over, and you can only imagine what that does when you're floating around. And so it's very important to work out at a minimum of 2 hours a day. I actually had a conversation with astronaut Stanley Love, who told me that he felt a little cocky when he went up the International Space Station and didn't want to work out the first 3 weeks he was there. He was there more than 10 years ago and is still feeling the consequences of not working out for 3 weeks. That's how dangerous space is, right? So we have to, as designers, create tools that motivate all of these astronauts to work out, but also optimize how they work out. Resistance, working out, resistant tools, as well as cycling or hiking, running on a treadmill and things like this. But that can get very boring. Another fun fact is that you cannot have 2 people work out at the same time because it actually throws off the orbit. And so you can control the orbit if one person is working out. Eventually we'll get there. But the way we design space stations at this point doesn't allow us to do that. And so if you have 6 astronauts working out 2 hours a day every day, they have to go one after another, and it gets very funky in there. But one of the things that we wanted to do is how do we immerse these astronauts into an environment that felt like the environment in where they work out is a lot bigger than it actually is, because these stations are quite small, right? And so projection mapping, AR, VR is fine in certain cases. Unfortunately, it may make the astronaut very, very sick, depending on how situated they are, the sense of proprioception, and things like that. So we, create different environments that actually work for the vast majority of astronauts. On the right side is, laboratories. A lot of what you see aboard the International Space Station are laboratories. So a lot of experiments done in physics, in biology, biotech, robotics, everything to manufacture pharmaceutical that can help humans get to care they could not if they only stayed on Earth. And other aspects of the space station module are thought that way as well, like the way you sleep, the way you balance safety with privacy. Maybe using colors and fluorescence and different use of lights to help regulate the circadian rhythm. Because when you're on orbit, on low Earth orbit, that's about 250 miles from the surface of the Earth, you are rotating around the Earth 16 times a day, which means that you have 16 sunrises and sunsets, and your circadian rhythm is completely messed up very quickly. A lot of our biology is based on that, our hormone system, our sleep cycles, and all that depend on it. So in many ways, we can use technology to support all of that in a way that does not reduce the cognitive and physical performance load of these astronauts, and perhaps make them live a little bit more comfortably, thanks to integration of all these technologies. So this is a 1-to-1 scale prototype of the life module. So it's about 9 meters in diameter. And I'm about to show you something really cool. This is a burst test. We are at NASA Marshall Space Flight Center, and they're about to burst it. So they're injecting air. There you go. So this is the second explosion. The first explosion actually blew the entire building it was in. That's what happens when you test things for the first time. But it's pretty cool to be part of a project like this. So that's introduction of the type of project that we do in space. Now let's come back to Earth. So these are human headphones. It's funny because a lot of people think that this product is fake. It came out 8 years ago. This is a product that was a little bit of an ode to natural design. Because I was seeing all of these products that were being developed to be on the body or around the body that were flat surface, black mirror, perfect line, perfect radii. And I'm like that doesn't fit any of us because we are made from like lofted surfaces and fractals and very complex geometries. Our ears, our faces, our fingers, everything is quite organic. And why do we force geometries that are not organic onto our bodies? So these headphones were developed quite a few years ago to basically translate natural design into a product that's completely revolutionary. So these are the first true wireless on-ear headphones ever designed. They look very clean and simple, but they were extremely complex to develop. Because if you look around the room, everybody has different ears. You even have different ears between your left and your right. We have small ears and big ears and meaty ears and uneven ears and sensitive ears. But creating a geometry that fits more than 90% of all adult ears and is stable on each ear was so incredibly difficult. Not only that, many different features of that pair of headphones also were natural. Like for example, in nature, there are no buttons. Why do we put buttons everywhere? To control what we design. So to turn these headphones on, all you have to do was magnetically separate the two halves. To turn it off, you put it back together. It's a very natural behavior. Instead of like pushing buttons to control volume up and down, you can actually slide your finger on the outer surface using capacitive technology, and then go to the next song and stop a call. This product also translated in 11 languages. So you walk down the street, people will speak to you in Japanese, and then if you turn the thing on, it would translate into your ear, so you can actually speak to the person in front of you, which is pretty cool. Remember, this came out 8 years ago, before all that like crazy technology you see in like your headphones today. So the geometry, as I said earlier, was very complex. And we're only able to get there by using 3D printing technology extensively. We created more than 700 prototypes of every aspect of this product. The outer shell to make sure that it fits the vast majority of people's jaw lines and ear geometry. On the inside, we had to like hook into the back of the ear, and they come in different sizes. The only basic surface of this entire thing is the flat surface on which the driver, which is the part that makes the sound, is mounted. Everything else is an insane geometry that would take me 4 hours to explain to you how we did it. But the battery was custom. There are like 6 magnets in this product, which is every industrial designer's fantasy, but we're actually able to do it. But the most impressive part of these entire developments is how we were directing all the other disciplines that were involved. I forced all the electrical engineers, mechanical engineers, acoustic engineers, UX designers, business people, marketing people, industrial designers to be in one room at least twice a week to make decisions together. Because when we were hired to do this job, they had been trying to solve this problem for 2.5 years, bleeding money like nobody else. And the reason why they were not able to solve the problem is because all of these disciplines I just mentioned never talked to each other. They were all doing their own job, thinking that they had the right to make the last decision. But the tandem kind of like dance between all of these disciplines and how we find common grounds between each of these disciplines' value and purpose ended up in a design that actually made sense. Not only did they function exceptionally well. The ergonomics were done to the point where you could actually wear those and do a handstand. I didn't put it in there, but there's actually a video of me 8 years ago doing a handstand with those, and they wouldn't move. But yeah, so it was surprising to see that all these people we work with at that company had never worked with other disciplines together. So that is what happens. You're able to come up with completely new ideas and end up with a product that's radically new if that collaboration happens. The next product is one of the most revolutionary things I've ever worked on. So we work with professors of psychology and neuroscience at UC Berkeley to develop this product. So you've probably heard of like Oura Ring and like other types of wearables that help you like track your sleep. A lot of the times they track, oxygenation or how much you toss and turn at night. And then it gives you information that might inform you on how to like better your sleep. But none of these products actually fix your sleep. Sleep is actually a neurological state, right? Like you sleep with your brain. A lot of people think that when you sleep, you rest your body, but first and foremost, you're actually resting your brain. You're allowing your brain to go through the natural phases of sleep. We're going to call them N1, N2, N3 in deep sleep. In deep sleep, you are basically removing all the excess information in your brain that takes too much space and nobody cares about. For example, the number of heartbeats you have in a day is actually recorded by your brain, but then deep sleep gets rid of that information to make more space in your brain. And so this product allows you to do that. It does actually two things. The band itself has electroencephalographic information. So basically EEG was what EEG stands for. And it reads, your alpha brain waves, your beta, theta, delta, things like that. And it basically records how your brain acts all night long and tells you if you had a good night's sleep or not. The part that's on the top and removable is the part that stimulates the brain. So the prefrontal cortex is the place where you can actually tell the brain what pattern of brain waves to follow 15 minutes before sleep. And then the rest of the night, the brain knows what to do. So it's a little bit like you have a kid on the swing and you're pushing them once, and then the momentum allows the kid to go back and forth again. So this product does exactly the same thing with your brain, just by stimulating with a little bit of electricity and lets your brain do the rest of the job. And that's one fundamental change that's happening in the world of medicine today. Before, for a long time, we have intervened in sleep or in other disorders. Like we take an Ambien to shut down the brain. So it shuts down the brain so much that you actually don't get the rest that you need. That's why everybody who takes Ambien is completely groggy the next day and never rested, right? But these kind of technology allows the body to do what it needs, what it already knows how to do. It just doesn't know how to start. And so it's pretty revolutionary just to do all that. And if you notice the design, very much like the human headphones, very inspired by nature. Because when we talk about sleep, we talk about some of the most intimate times of our lives. We spend a third of our life in there, surrounded by hopefully comfortable textiles, colors that are very calming. We don't want something that looks like it came out of a research lab at a university, which is usually like white and with a bunch of wires and very weird. But what we wanted to do was to bring sensuality to the way we design things, inspiration from nature. The waves are an expression of the brain waves as well as calming mountain sights. The charger is based on riverbeds. So everything is very, very organic and really fits the body. The material, we used silk. On the one on the right, we actually tested the dyeing silk, like pink silk in different temperature, as well as we boiled the silk with avocado seeds, and that allowed us to like create this like very beautiful gradient. So our soft goods prototyper at the office comes up with ideas like this, and it's pretty incredible. So adding as much natural material as possible. The padding, we could have used like this very artificial padding, but we really wanted the material to like breathe through. So like a cotton-based padding that was like very open was necessary for that. So we're involved in every process from branding, industrial design, prototyping. Here you can see Igrim making hand prototypes using different silk that she dyed herself. She also involved in like CMF, colors, materials, and finishes. And so every single aspect of the brand, of the experience, is not only consistent, but it also aligns with the user experience around the bedroom, which has to be quite soft and friendly to the body. Now let's talk about working out. So you'll see, like, we do a lot of work in neuroscience because San Francisco, where our office is based, has one of the greatest center for neuroscience there. And so this product was made like quite famous a few years ago. So this is a product that's designed for the body to learn movement faster. So the way the brain learns movement is when you stimulate the primary motor cortex, which happens to be on top of the head, during warm-up, for the next 4 hours, your body actually knows how to do things. And the way it does it is by reaching what's called a state of flow. So I don't know if any of you run or work out, but the first few minutes of like running, you're like, ugh, I hate this. Why am I doing this? I don't like it. Then all of a sudden your brain changes states. It's like, oh, I'm not thinking about putting a foot in front of the other anymore. I'm starting to enjoy it. And then that's where your endurance, builds over time. So that's what we call the state of flow. And instead of like suffering every time you start a workout, you can actually do that artificially by using this product. So it applies electricity to the primary motor cortex on top of the head. You will use it for 20 minutes, and then athletes can actually get to their peak performance after those 20 minutes. So this was used at the time by the USA team in cycling and other Olympic teams. And it could shave off significant time of their performance, because during training, they would spend a lot more time in peak performance than they were before. We live in a world where the difference between a silver and a gold medal is no longer talent. It's actually technology. So might as well use it. A lot of the work that we do has to do with making a lot of that exceptional technology and bringing down the cost and making it available to everyone. So a lot of people thought that this product was only available to those like athletes. And at first, the first generation of the product was quite expensive. It was like about $800 a pop. And then our client wanted to make a second generation that was that expensive. And we actually convinced them to bring it down to $350. And we did that by increasing the comfort of using these products, by simplifying how it's manufactured, by reducing the number of factories involved in manufacturing it. And it's by reducing it, you were able to like make the technology available to a lot more people. It was so popular, they sold out multiple times. And after a couple of years of selling those, they were acquired by a company that is actually using the exact same technology to use it to reverse the effects of depression. Talking about depression, we also get to design brain implants. So brain implants sounds very scary, but they can actually be life-saving. There are different types of brain implants. There are deep brain stimulation, which is going to be like very effective for epilepsy and a lot of like life-threatening conditions. This one in particular was designed for treatment-resistant depression. So TRD is a condition in which you have tried everything, like talk therapy, cognitive behavioral therapy, medication, group therapy. You've tried it all and nothing works. There are certain brains that simply are thinking about committing suicide every single waking hour. But there's a technology that's been around called transcranial magnetic stimulation that is available in hospitals. So basically you sit down on a chair, you have this machine that magnetically stimulates a very specific part of your brain, and within 5 days of sitting there for 8 hours, you feel a lot better. Your mood is reversed, and usually it lasts for about like a month or two, and you have to come back for like maintenance. So that is very effective, which is great. However, not everybody can afford to take 5 days out of work just to get better, right? On top of the stigma, and a lot of people who are depressed are not necessarily motivated to go to these hospitals and do that. So what we did here is develop this brain implant system with a startup that came out of Rice University in Houston. So basically, we are taking this exact same technology and making it very small, the size of a pea, and then we're putting it in the thickness of the skull that you can see right here. Oops, back, come on. Okay, so the thickness of the skull has this like brain implant that stimulates that very particular part of the brain because it's in a different position slightly for every single brain. And then we develop a hat that actually has all the big components, like the wireless power system is actually inside of the hat. It can be controlled by, this controller that you see, you can put in the pocket. We also designed a user interface to look like you're controlling your brain, very much like you're controlling an airplane. So a lot of inspiration from these like cockpit dials and things like that. So it's pretty revolutionary. What's really, really cool about the company that we're developing this with is their board, advisory board is made of 100% of people who suffer from treatment-resistant depression. So when we test the product, when we ask for feedback on how to go forward with this very revolutionary product, they're giving us like very honest feedback, because it's very hard to imagine how someone who suffers from this level of depression makes decisions for themselves. So besides just like sitting down with a bunch of people for like user interviews to give us like things that are nice to have, they actually give us a lot of the truth, which is, we got to learn a lot from that. Okay. Next, so I don't know if any of you are seeing a lot of these like humanoid robots, but they're everywhere. Whoever was at CES, the Consumer Electronics Show in Vegas every January, this last one that had like a floor full of them. There are many different purposes for humanoid robots. What's interesting is also our relationship to the robots themselves, right? So some of them are used in factories to like supplement a human workforce. They can work pretty much all day, all night. You don't need to pay insurance. If something breaks, all you have to do is like update the firmware or replace a part. It's gonna be quite revolutionary, especially when like more and more demand of like consumer goods are gonna happen in the future. We've worked on a few of them. Some of them work in factories and are great for logistics. And we're currently designing another one, which is not this one, for assisted living. So supporting people who are aging in their physical and their cognitive abilities, helping them remember, or helping them communicate, because a lot of these elderly people living in those senior facilities kind of like, are by themselves, really have a hard time communicating with other people who are living in the same environment, don't see their family very often, and don't really use their brain and their physical body very often. So having these robots support them in very significant ways, not only support those seniors, but also support the staff that's helping, flip those seniors when they can't move at night, and things like this it could be quite revolutionary. Continuing on robots, this one's pretty cool. So there's a lot of people, like billions of people on this planet who don't have access to care because they live, hours away from the next hospital, and some of this hospital can't even call them like this. It's just like a basic clinic with not enough equipment, and so. In order to develop the future of telemedicine, we can develop like really, really cool new technologies. And this one is basically a robot that you can swallow. So the idea here is like in the United States, which we have plenty of like level 1 trauma center with ER, neurosurgeon, and all that. It's very, very difficult. It takes a long time to get an appointment to get your upper gastrointestinal tract checked, right? It might take 2 or 3 months for you to get there. You might be suffering from an ulcer. You might be developing like stomach cancer. You're not going to know for another 2 or 3 months that can be fatal, right? And so the idea of the Pillbot by a company called NDIDX, which is based in Silicon Valley, is basically it's a team of aerospace engineers and biomedical engineers who came together to create a bot that you can swallow. Obviously, we're not going to swallow this one.
The inspiration actually began earlier.
Anyway, This is a video
Once
about
you see
it.
this movie called Inner Space, you just sort of assume when you're young and you see stuff like that it's real in some way, or that it will be real in some way. The question we ask is, could we maybe turn a couple of months of visits to the hospital into a Zoom call? Our dream of creating a pill bot is kind of beginning to become more and more real. What you see right here is kind of where we are right now. And what is it going to look like in the future? Like, do we make it smaller? Maybe it could be like the 2001 space pod, the little robot arms that come out. Pillbot is now micro-sized. It's in your brain, and we might be able to catch things like cancers like tens of years before you might otherwise catch them. So here's the future of telemedicine.
So we get to work on really cool things like this. If you guys watch Mythbuster, Adam Savage swallowed 2 of those. And if you're wondering where it goes out, you poop it out. At this point, it's about 11 millimeters in diameter, which is like too big for general consumption. We're trying to like break it down to maybe the size of a grain of rice. So eventually it's going to be so small, like he says in the video, that was the CEO, that we want to go in like very intricate parts of the body. We're working with MIT right now, and they're developing some what's called nanobots. So basically treating neurodegenerative diseases with robots that can be injected very much like a vaccine. So it's pretty awesome. So you can see like a little bit more of the robots here. What's really cool is that we also, telemedicine for the most part is like based on diagnosis at this point. You spit in something or you swallow something and you ship it to your doctor, but this is actually real time, or a doctor on the other side of the planet can actually control this robot that's inside your stomach and see in real time if you're developing stomach cancer, for example. So it's pretty revolutionary. All right, next, let's talk about optics. So firefighters have a big problem when they enter a burning building is they can't see anything. It's a little bit different from like what you see in movie. Usually you have like those dramatic flames and, it's raw, you have someone in the corner. But like the number one problem is really visibility. And so what would be very helpful is if firefighters were able to see the edge of everything. And so we're using augmented reality technology and thermal camera imaging around oxygen masks that are pretty standard, especially in California, this model. And so basically we're creating this like rig that allows these firefighters to see through smoke, the edge of everything through smoke in real time. And so yeah, we're able to like develop this product with this client, and it's pretty revolutionary. So what's nice about this is that it allows for these firefighters to shave about 15 seconds the time it takes for them to pull out a person from a burning building. So that can be life-saving for that person, but as well as themselves, right? Every year we lose quite a few firefighters to the fact that they leave this building too late. So you can see the difference here. On the left side is what's going on with regular flashlight. On the right side is what you see with this technology. So technology can really be life-saving if it's used in the right way. What's very interesting about the way we developed this is we had to really study how firefighters actually use their eyes. So they're trained to never like move their eyes like this. They have to turn their head and they have to look at things because they have the mask on, they have like the hard hat, they have like 2 layers of gloves and I don't know how many layers of like clothing. You can't have a lot of mobility. So when we integrate all of that technology into something that's already quite tight, we have to work with the way they're trained. And on top of that, because they have such a life-threatening job, telling them to integrate technology where technology can fail, because technology always fails at some point, was another level of convincing. And the only way we could do that is by testing it with them and designing the system in a way that if it fails and when it fails, they can still use their training and their remaining equipment to do the job that they have to do. They can still see through the AR lens. They can still use their mask the way they need. They can still like move their helmet if they need to. It just is there, as a dead product. again, a lot of like 3D printing, like fitting. There's not a lot of space in those oxygen masks to begin with. So we had to like fit, batteries on one side, PCB, the AR thing, making sure that it fits like different width of eyes, making sure that on the outside you had like, I think it was the page before, you had like buttons. When you create buttons for fingers that have at least 2 layers of gloves, and you can't see anything, you can barely feel anything, that's like very critical. So a lot of that testing was done throughout the process of designing this product. This one is, what's interesting about it is like the product itself is like whatever. Like, so when we started Nonfiction 10 years ago, our first client was Intel, which sounds very impressive, but I could not wait to fire them. And the reason for that is because what they do is like not that interesting. However, we used a lot of work in computational design to help optimize the way their computers cool. And that was used on a collection of product called the Nuke series of computer that came out a few years ago. We added some like nice colors and work with the thermal engineers to see, where we can optimize the ingress and outgress of hot air. But what's interesting about this is the business model. They were selling these computers to like B2B or like outside the United States. They're actually quite powerful computers for a very, very small footprint. And the business model that was very interesting is we stopped working with Intel because this whole department got sold to Asus for $500 million. So, yes. So now let's jump into a completely different world. So I was born and raised in Paris, and the first part of my career, the many first parts of my career, but one of them is developing products for the luxury industry. And so when I was like, 19, 20 years old, I was working on the Champs-Élysées, designing like super high-end handbags. And it's funny because I don't have any love for handbags whatsoever, but I like the craft that comes with it. The fact that we're able to use centuries-old techniques to create products that have a longevity, and when we think about sustainability and creating products that age beautifully, can be passed down from generation to generation, I think the luxury world is a wonderful place to start because we've been doing that for like quite some time. So I think it was about 14 years ago, I started this company called Eternal Luxe. And we basically created this marriage between traditional leather crafting. And what I mean traditional is that no machine was used to make these bags. All the stitching was done by hand, stitch by stitch, using what's called saddle stitching techniques. But we merged that with contemporary design, gender neutral design. So this collection in particular was shown at the time at Shanghai, Tokyo, and Paris Fashion Week, with the Japanese fashion designer. So as you see here, a lot of like techniques. Some of them I was taught in leather crafting school. Some of them we came up with ourselves, but always coming up with like the most precise way of taking a natural material, either a 2D material like a thread or a 3D material like a piece of leather, and transforming into a 4D material that moves through the body. So pretty interesting to work in like this like super extreme cutting edge technology, and then coming back to building something by hand that sustains the tradition and the craft that's been created a long time ago. This project that we did with a company called Jazza is one of the most rewarding things I've ever done in my life. So basically, in countries like Tanzania, in East Africa, and Nigeria, in West Africa, in some villages, power coming from the grid is extremely unreliable. We're in a village in Nigeria, and they were telling us that out of 30 days of the month, 28 days were without power coming from the grid. And the rest of the time, if need be, they had to buy very expensive diesel and use diesel generators, which I don't know if you know, but are extremely loud and polluting. And so these people who live on barely like a couple dollars a day for the entire family, like could not afford, to buy batteries or to, replace what they had today with renewable energy in a way that made sense for them financially. So work with this company that allows for them to not buy the batteries, but to rent them. And then we also designed this microarchitecture you see on the right side. This was the very first one that we built in Lagos, Nigeria. And we actually installed it about 5 hours north of it. We had to have like armed guards like in SUVs to go there and then install it ourselves because it can be quite dangerous. And so these microarchitecture are topped with solar panels that are manufactured and shipped from China, but everything else actually came from and was manufactured in West Africa. And so what's great about these is that you have these microarchitecture that are built in one day. Everything from is flat pack. You can put 4 of these on a truck, go from village to village, install them one at a time. Because power is very limited and the skills of the workers putting it together is very limited as well, where we had to like build all of these with minimum amount of tools, right? So it's basically, a little bit like assembled, pre-assembled in flat packs and then put together on site. 100% of the operations of these little kiosks are done by young women. So at this point, they have 4,000 of these women spread over Tanzania and Nigeria who tend to the customers. So the customers, a lot of them are very poor. They don't know how to read. They don't necessarily understand how things work. So you have these like community builders who are between the age of, I would say, 18 and 30. These are women who otherwise, like if they didn't have this job, would probably be married off after high school and expected to raise a family and not make their own money. So the company we work with, Jazza, makes it a point to not only employ them, but also pay them more than anybody else in the village. So we're basically developing this whole ecosystem of women empowered power system. And it's pretty incredible to see that. So you can see the way we designed it is very, very specific to these regions, right? Because when the client came to us, they're like, oh, you're from Silicon Valley, just make something that looks like an iPhone. I'm like, that's dumb. Let's actually look at how people live, what kind of colors they wear, what kind of patterns are seen on their contagious fabric, for example, and integrate as much of that as possible in the design of these products. We're not only able to do that, but we're able to do that at a very low cost. These batteries, they come in 2 sizes. The small size that you see at the bottom here, can power up to like 4 phones. And these are not bought by the customers because they can't afford them, but they're rented. They can rent and swap them as many times they want every month for $3 to $4 a month. So that allows them and their families to have access to renewable energy. The bigger one that actually just launched literally 2 days ago was designed so it can power a 40-inch TV, a stereo, which not only allows for like entertainment. We have to think that it allows for light to be available at night, so they can cook at night. They can have like community events. They can charge their phones so they can have businesses. They can have stereo so they can entertain the customers if they're cutting hair or whatever. So there's a lot of like social transformation that happens from offering this kind of like super low cost solutions to these communities. So you can see here the Jazza Star, which are these ladies who do all this. They use their own phone to check in and check out if the batteries. We also design everything on the inside, the inverter. You can see me on the right side dying of heat, like it's like 110 degrees outside. Yeah, of course, there's no AC anywhere. I'm just like very delirious, but extremely happy to see these being used by the community immediately. All right, so now let's jump back into space. One of the biggest problems that you see for the future of humans in space, a lot of people think about rockets or keeping people alive. Like, we're actually pretty mature when it comes to things like this. The number one problems that we don't have a solution to today is food in space. Because right now we can guarantee food to be pretty stale and you can guarantee that the food can be consumable up to like about 2.5 years, depending on how it's prepared. This afternoon, I was actually at VAST, which is like 15 minutes from here, talking to the head of food, space food, and we were discussing this. And so basically the idea here is to create a microgravity space kitchen that would be integrated into a space vehicle that would go from the surface of the Earth to the Moon to Mars. So this round trip, would be 3 years. Mars is very far away. And during those 6 to 9 months, it will take for us to get to the surface of Mars. We need to feed these people, and we can't feed them the same freeze-dried food or like MREs, which are like ready to eat, like military style food for those nine months or 3 years. Otherwise, you go crazy. And so we created this system that we also prototyped that grows microalgae, which has been shown to protect cells from dangerous levels of radiation. We also have a garden, not only allows for these astronauts to have access to like fresh food, but it also, the idea of a garden that you tend to actually supports people's psychology. We also had a space barbecue. So as you may know, barbecue requires fire, and fire is frowned upon in space because it's a rich, oxygen-rich environment. And you can't like risk the life of everybody just to have like a nice piece of meat. And so we developed this like specific laser so basically the way you use it is that you would rehydrate a piece of protein, you would add a layer of carbohydrate on top, and then draw whatever you want. It can be like grilled marks, like you can see here. You can write your name if you want to using lasers, which not only gives an appetizing look and feel to the protein itself, but also gives it like this caramelization flavor that makes the food a lot less stale. So yeah, we developed this for NASA. And that was like for a big competition. We won the phase 1, and yeah, it's pretty awesome. So one thing about space is that not a lot of people have been in space. Since the first person has been to space, we've only sent about 700 people. That's it. A lot of these professional astronauts actually go back up there multiple times because it takes so much time, effort, and risk to train them. But one thing we can do is actually test a lot of that on Earth. And so there's a specific type of mission called an analog astronaut mission that we could go on. So this is me wearing backpack number 5, about 800 miles away from the North Pole on an uninhabited island with my crew of 4 people. So we were dropped off on a Twin Otter, like very basic charter airplane. We stayed in that research station called the Flashline Mars Arctic Research Station. It's been there for about 25 years. It was put together there by the Mars Society. And basically, and you can see where it is on the left side here. So basically, we go there with everything that we need, except for water, because there's a stream right there. We bring all of our food, all of our thermals. We have access to power 3 hours twice a day. And the rest of the time is the Arctic, so it's cold. We go there in the summer, which means that there's no nighttime, 24 hours all the time. So we block different aspects of, lighting during the night to make sure that our circadian rhythm is supported. The reason why we go to Devon Island, which is the biggest uninhabited island on planet Earth, is because there's a giant crater on that island that allows us to do a lot of research in climate change and what's called in situ research. Resource utilizations, which is taking basically rocks and extracting what we need from it. So for example, gypsums, which is like this white rock that you see like near rivers typically, gypsums has 30% of its weight is actually water. So the idea is to go on the surface of Mars, instead of like bringing very heavy and very expensive water all the way from Earth, you would go to the surface, extract gypsum, extract the water from it, and then utilize that water for multiple purposes. Not necessarily drinking for the first time, but you can use it to create cement for architecture to protect you from dangerous levels of radiation. And so we're in that station, and one of the jobs that I had besides being crew commander is to make sure that everybody was comfortable. So I was supporting sensory well-being. I added this like blankets, because of course the thing was designed by engineers and has like no soul, nothing. So added that, a cooked meal that tasted like food, not this like freeze-dried awful things that they give us. We did some art pieces. I changed the color of the lights and the sounds that were in the station every morning, midday, and night to support the circadian rhythm and making sure that people were actually getting the rest that they needed. Laura, who's like with the drill in the middle, she was the crew psychologist, and she had us use this app every day to check our level of fatigue, burnout throughout the day, and make sure that we're all psychologically capable of doing all the tasks that we had to do. We're only a crew of 4 people, and so we had to do a lot of things. The power went out every 30 minutes. The pump that supplied like water, was like just kind of a trickle. We couldn't like collect trash, so we had to like reuse a lot of things. It was like pretty incredible how basic life is up there. So we were just there for a number of days, which is totally tolerable. But imagine people having to go to Mars and back for 3 years, be on the surface of Mars for a year and a half, and then live this way at 1/3 gravity. So it's pretty extreme. And so that's one of the ways that we test different systems, the life support systems, the hardware systems, the software system, and the human system, which is very unpredictable, and see where all this is going. Very interestingly, my mission, which is Mission Crew 17, went perfectly. Everything about mission, like we got along, we ate fantastically, we were getting the rest we needed, everybody was in a good mood, and we all talk about this. It's fantastic. Crew 18 came immediately after us, and it was an absolute disaster. 3 of them forgot the thermals, 2 of them forgot their sleeping bags. 1 of them had to be evacuated because he was an idiot. And so all of this is done in one of the most isolated places in the world. On top of that, we had imposed on ourselves a 40-minute delay in communication because that's what it takes to go to Mars. And so everything from the evacuation and all that was done this way. And so as that person who was evacuated was isolated for a couple of days because they were threatening their own life, and this is the whole thing, I was on the phone with the crew with a delay of 40 minutes trying to like deal with the rest of the crew, like the ones who forgot their sleeping bag. Because I was there before, I knew what kind of materials were there. So I would be on the phone and telling them, go to this room, there's fabric. Go to this room, there's a sewing machine. Go to that room, there's foam. Assemble the thing together. This is how you like make a mock sleeping bag. And we basically saved the lives of like 2 people by doing this. So being in this situation, being in these like life-threatening situations is where you learn the most about how to best design for human stupidity, really. So yeah, so you can see a little bit more here, like integration of plants. Obviously, because we're in the Arctic, I'm not going to bring real plants that would die within a month. But just the idea of bringing like these like plastic plants that I found on Amazon and then creating a little bit of that like green wall really supports people's well-being, something to tend to. Same thing for the smells. There were like very specific concoctions of essential oils that were mixed together that really, some of them wake you up. Like for example, when you go aboard an airplane and you go on a red eye, you will notice that in the morning, when they start turning on the lights, they will spray some lemon scent, because lemon has been shown to actually help wake up the brain in a way that's like very, very calming. So we use the same principle there. Every time we went out, we use extravehicular suits. I can use the word spacesuit because it's not pressurized and all that. But yeah, and we're also trained to like deal with polar bears if we had to. So we're all trained to do that. The last thing I wanted to present today is an organization I've been part of for about 2 years now, called the Organization for Space Medicine, Engineering, and Design, so called OSMED. And so I served for a year and a half as the chair of design at OSMED. And so it's basically the top space medicine experts, space engineering, and space design or architects that have basically pledged to work together to make the future of human spaceflight safer and more inclusive of all. Because right now we've been pre-selecting very healthy people to essentially not die up there. And there will never be a space economy. There will never be a future where we could see ourselves going to space if we continue working this way. So collecting more data, understanding how to design for people who are not perfect and not, don't have MD, PhD, and, not superhuman physically is so incredibly important. So we're working with astronauts and we're working with a lot of people like this to really overlap all of these disciplines and make them work together. We've authored quite a few white papers so far. I'm about to actually publish a paper called The Value of Design in Human Spaceflight that I worked on with an Israeli space architect. We work in all the systems, spacesuit systems, medical systems, and we break it down in a language that's actually understandable by anyone inside or outside the space industry. So translation of very complex information is so incredibly important. And then one of the projects that I am starting, that's about 2 weeks old, is I am now the project lead of a project called Orbital Hospital. So we're actually going to design, engineer, and build mock-ups of different aspects of what an orbital hospital is. Because right now, the only access to care that you have is what they call the medical bay or some certain very basic tools. There's nothing that's can take care of surgery in space at this point. And if we're going to send people to the moon for a long basis, or bring them back to from Mars, we'll need a lot of orbital access to health. So behavioral health, preventative health, acute care, psychological support. We also want to use this station to help with analog missions like the one I showed you on Devon Island, but we want to do them in space so we can actually test 1/3 of gravity, which simulate the surface of Mars, or 1/6 of Earth's gravity, which would simulate the surface of the moon. Because right now we have zero data on what these environments do to us. Because only a handful of humans have been to the surface of the moon. It's only been for a few hours, so we know nothing. And so I started this project. We are, I think, 50 or 55 people so far. This project is 2 weeks old. And basically, we are inviting everybody who has skills in space medicine, engineering, and or design to join and help us design this thing together. And so if you want to participate in this project, you are welcome to go to osmed.org/membership. You would become a yearly member of OSMED and have access to all these wonderful people, very nerdy. But you will also be involved in helping me and the rest of the team design this orbital hospital. So yeah, that would be really fun. So one last thing I wanted to share with you is education. Since we're an educational institution here, is very important. So I used to teach industrial design at California College of the Arts. I don't know if you heard, it's about to close. But I taught there from 2016 to 2020. And when the pandemic happened, teaching changed a little bit. And so I decided to produce a whole video series called Future, where my partner, Modest, and I are on screen and talking about design, how we practice design, and the future of everything. So that's about 47 episodes on YouTube, spoken in language that is accessible by everyone. People in design, people outside design, people who don't believe design has any value. And that's on top of the advisory work and the work in teaching creativity to the military, law enforcement, and all that I do, because I do a lot of things on the side. But really, design education is so incredibly important, and that's going to be like half of the work that you do as professionals. You're going to do the design work, you're going to climb up the ladder, become managers over time, but the whole way you will have to teach everybody around you what design is, what its value is, and why they should pay you money for it. That's what I have today.